Hello, everybody. I'm really glad to be here. And before jumping forward, I'm here to present the results of my research. These results are from something like a year and a half ago. So, as far as I've been listening, the latest sessions this couple of days, there's a lot going on, and I'm thinking it's pretty much in line for what we heard, and probably there's a lot that can be concluded as an improvement for what I'm going to talk about here. The first thing is just like I've been in the enterprise IT business for the last 25 years. One of the few things I learned from it is just like there is no perfect solution. That's number one. So we got like the good enough solution. That's for IT. The second one is just like it's pretty much like a hybrid world. It ain't like that perfect, pristine technology solution over there. Pretty much in order to make it work for business, you got a bunch of different systems working so that lead us to think like it's okay to think into a sort of hybrid solution for how we take the quantum promises and make it kind of real to the real world. So based on the latest political and sanitary issues we faced, one of the important things that it's been pushing forward is just like there's a bloom in the e-commerce, especially during the last couple of years ago. So what we see is just like uh, we're getting an increasing feedback in terms of how the optimization scenario is something worth analyzing. So what we get here is just like, let's say, for instance, from the Boston Consulting Group, we get an estimate market in terms of the optimization scenario could represent something between 50 to 100 billion dollars, pretty much in line with the insights from McKinsey. So that being said, the way we faced the research was pretty much understanding what's the addressable market. If there is in a business case, you know, when you're in IT, you pretty much have capex for breakfast, opex for dinner. So you're pretty tuned to understand if it's reasonable business or not. And then from the business perspective, we are moving into how to tackle that problem. So that being said, when we face this scenario, pretty much we jump into understanding how the retailers locally, in my case in Latin America, my co-researcher in Spain, were facing these kind of issues. And probably you already faced that when you were locked down. They were having some kind of issues in terms of the delivery specifically. So we decided to understand the supply chain and then figure out how to tackle one of those pieces of that supply chain. So in this case, we focus on the retail and logistics, and understanding this impact, we decided to analyze the delivery market in Europe. And we got this data that's from the Spain market, representing that how it represents in terms of the business impact from the optimization scenario. So going around into understanding how the retailers work, what we've seen is just like we got a chance to interview a couple of them, and they let us know that what they're seeing today is pretty much like they're facing the problems in two mainstreams. One of those are data consumption, and the other ones are pretty much a computing consumption. So we've seen that there's a huge investment on the data side. So that means that there's room in order to grow on the compute side. So for the scenario we went through, the data that we were able to get is pretty much like this. We estimated like in Spain, we get a 27 billion market side, which is a market which is usually growing into a sort of 16% compound growth year over year. Having in mind that there is a 10% margin benefit of it, and considering with this data that we may be able to get any kind of 1% saving, it represents an estimated saving of something around like $8 billion compared with the initial estimates that we created, that we thought in this scenario that acquiring the computing power plus acquiring the services and the pretty much the brain power for it. During the time that we were doing this analysis, what happened later is just like we started to see the growth of some national initiatives. So we decided to reduce our optimisms and fine-tune that estimations in order to make it a little bit more aggressive. And the result was pretty much like based on the latest reports that we got then from the Euro network and the human capital investment, we moved the investment from 5 to 25 million. And that pretty much still means like there is room for making a positive return on investment. So we decided that it was worth the business case. So then we needed to choose which problem we were tackling. And in this case, considering the last mile scenario, we decided to face the problem from the vehicle routing problem. So having this in mind, that vehicle routing problem represents like a traditional optimization problem, we decided in order to face this, we were limiting the options to evaluate in order to make it tangible for us. So we established a set of constraints. First, we choose the capacitated vehicle routing problem, and then we define some few additional constraints in terms of determining how we're moving from a single depot, defining an homogeneous fleet, and eventually defining these kind of cloud routes. What we decided in order to follow a strategy to face the problem was first dividing or splitting the problem into a classical mode and a quantum mode. And in addition to that, in order to make a better use of our resources, our limited resources, of course, like everyone else, we decided to split the problem from the classroom perspective and the router's perspective. In addition to that, we also decided to try a pure quadratic and binary, quadratic and constrained binary optimization problem, fully quantum, and then compare with the rest of the scenarios we tried. So that being said, the strategy we follow was pretty much like this. On the hybrid algorithm, it is like splitting the problem in different scenarios, which first help us to reduce the complexity, and in order to increase the parallelization of tackling different travel assessment process in parallel in contrast to following all in a line mode. So we decided to go with a class first, route second approach, and that meant we follow these approaches in terms of the clustering and routing. So first, let's see, the hybrid algorithm goes like this. On the clustering phases, we compare the k-methods against the QUBO clustering. From the k-methods, the strategy goes like understanding what are going to be the grouping points, how we're going to be clustering and defining what are going to be the nodes to arrange the routes within it. We decided to establish an additional constraint in terms of delimiting the closest path in terms of how they're going to be close each node to another, and in comparison with the random approach initially. And on the other side, we pretty much established the QUBO clustering, establishing these considerations in terms of how these nodes were supposed to be split together. And the other approach, from the routing phase, we decided to go with a QUBO routing approach, which pretty much established a Hamiltonian in order to consider those constraints we established initially. And in addition to that, we added an additional Hamiltonian in terms of considering a limitation in terms of the distance or the edges of the nodes. So that's the formulation of the problem. And on the classical side, we follow the traditional combinatorial approach, following the Google or R tools in order to find what should be the best approach to try to get the travel assessments approach. And the good thing from this combinatorial optimization was pretty much like with the Google tool, we were able to balance the local optima that are arising from the heuristic in contrast with the global optima. And we also tried this QUBO CVRP. The QUBO CVRP main equation looks pretty simple at the beginning, but it starts to get complex in terms of establishing the constraint in order to make it work. And the constraints start to make things quickly quite complex, especially because we have some of those constraints like inequalities, which greatly increases how these variables are going to be limiting the problem. So those are the strategies, the 5 approaches we decided to analyze. So and the results we got from here is just like, first, we tried these results initially with a digital annealer, a simulator, and then with some additional support, we moved into trying this result with the deep wave quantum system using AWS Bracket. So the results we got over here, and limited in the scales, of course, is just like on the clustering scenario, comparing quantum versus classical, what we got here is just like on the scenario where there is low clusterability, we get better results from the quantum scenario. In the scenarios where you have a higher clusterability and you can establish this kind of initial groups by default, the classical results tend to perform slightly better. So this is an interesting one because it shows us that there are scenarios where the quantum results tends to perform much better in terms of the calculations of the distance and the results in terms of computation and errors. In general terms, we still see a lot of computing time increase from the quantum approach. So that's something like we cannot give as a base that, due to the maturity of the quantum technology yet. And on the other scenario, on the analysis from the routing scenario, we've got these results. In the routing scenarios, we saw that most of the time, the classical algorithm tends to perform slightly better than the quantum routing, right? Now, the positive perspective from this is just like even though their quantum result it ain't better than the classical one, it ain't that far also in terms of the calculations and the results of how good are the distance calculated. We still have a lot of cost in terms of computing power again, but from the perspective of designing a best route, it ain't that bad. But for that one, we still consider that the classical make it better than the quantum one. And last but not least, for the CVRP, we didn't get pretty much well results due to the complexity. We saw that given that the constraints have to grow exponentially, the results in terms of computing and calculations, and especially when we grow in terms of slack variables in order to maintain control of the problem, the results of the calculation weren't that good enough. So in this context, the final conclusions for our work was pretty much based on the first, we do have a business case scenario where when we say like it's worth trying and investing on it. The results that we got with the current state-of-the-art quantum technology shows that there are areas where the quantum approach may provide better results than the classical words. And this pretty much shows us that we got the hybrid approach pretty much worth trying. So the final conclusion for our work is just like when we get these results and we get the way the technology is growing and the maturity forecasted, we expect that the quantum is going to provide better results in a shorter term. And that's pretty much the results of my conclusion, the results of my research. In addition to that, there are a couple of slides showing like as annex of the research that you can find on arXiv, the clusterability approach and how we calculated the clusterability in the terms of the clustering phase. Also, in interesting feedback from here is just like when we move from the simulator to the actual quantum hardware, we face a couple of interesting problems. One of us was that we needed to embed the problem into the processor topology. So that limited our way that we could grow or scale in terms of rearranging our algorithm again. That, from our perspective, was economically limiting since it grew exponentially. Then we just ran out of budget, and we tried this control scenario for that. But on despite of that, we still believe that the results shows that basically there is room to try the quantum approach, mix it with a classical, and try a kind of a hybrid solution. Just this last slide is pretty much like the data set we use in order to try and test and compare the scenarios, and that's it pretty much. So without further ado, thank you so much.
Any questions out there?
Thank you. Simple question. How many variables, how maximum number of variables were used for the problem that you solved, both on the classical and the quantum?
Those were pretty much based on different data sets that we tried. Let's say, for instance, for each one of those, we tried this kind of 50 data points, 70 and 200, and we tried each scenario. So in every single scenario, we get some different results, depending of how the algorithm behave on due respect to the data. And that's it.